All right, so I'll be sharing my screen with you. Now, the very first thing that I would want us to do is to first look at the exam outline or the exam structure. Look at the exam areas or the content areas for numeracy. I believe you can all see my screen.
Yes.
All right. So we're going through the topics first. Then we would come to looking at what to expect in the exam. So I want to show you this. This course is the professional general knowledge. Professional general knowledge. And this course comprises of 3 sub areas. These sub areas are literacy, numeracy, and essential skills. According to the exam structure, it is telling us that literacy is going to cover 60%, sorry, 30% of the marks. I believe you've seen it, 30. Literacy will take 30% of the 100 marks that you are supposed to attain. Also, essential skills will take 40% of the marks. Have you all seen that? Please,
Yes,
are we together?
Yes.
Right. So this tells you that numeracy will also take what percentage, please?
30.
30%. So that is the first thing for us to know. Now we know that we are supposed to strive as much as possible to gain a maximum of 30 marks from numeracy. Now, these 30 marks we are supposed to gain in this area, these are the topics to which we are expected to be able to have a comprehensive knowledge about, so as to be able to score all our 30 marks over here. So let's go through the topics one after the other. Now we have one, or the main domain here is the number. So under number, the topics we are expected to know about are base 10 numbers, right? Including decimals and integers. So when we say base 10 numbers, what are base 10 numbers? Anyone to help us? That is just a mock-up we are doing before we kickstart. So base 10 numbers are going to be our focal areas. And we are saying base 10 numbers including decimals and integers. So please, I ask, what are base 10 numbers?
Base 10 numbers are numbers.
Hello. Yes, you are listening.
They are numbers that are written without points or dots. So if it is 50, you write it 50 without adding 50.0.
Okay. So someone has try defining base 10 numbers. Any other? All right, so next we'll be looking at the 4 basic operations. So when we say the 4 basic operations, we are simply referring to the addition, subtraction, multiplication, and division. But this time around, we are going to apply them in what? Multi-step problems. Is that okay? We are going to look at the 4 basic operations in multi-step problems or word problems. Beyond that, we have set of numbers. Sets of numbers. I believe someone is jotting down these points I'm saying. So under set of numbers, we'll be looking at factors of a number, multiples of a number. We'll be looking at prime numbers. We'll be looking at exponents. And then we'll be working with these notations. So please bear in mind, in all, we'll be considering at this alongside decimals, fractions, percentages, and ratios, while we are dealing with the factors, the primes, the exponents, and all those numbers. Next, we would also be looking at fractions in a more detail. Now, under fractions, we'll be looking at converting fractions into the equivalent forms. So, decimals, percentages, ratios, proportions. All these are areas we may be assigning or trying to compare these fractions to. Next to that, we'll be studying ratio and proportion. Ratio and proportion. The topics are quite numbered. However, for the purpose of today's class, which isn't meant to be a general briefing, I would restrict the exposition we are having on the numeracy to these subject or topic areas we have just highlighted. So we're going to be looking at base 10 numbers in general, decimals and integers. We will try to extend to look at sets of numbers where we have factors of various numbers, multiples of the numbers, prime numbers, exponents. We then try to look at fractions, comparing them to decimals, their percentages, ratio, and proportion, ordering of fractions, etc. Then finally, we'll be looking at ratio and proportion. I understand our time will not be able to make us go that far. However, to the extent that we'll be able to go, I would ensure that we'll be able to cover and at least have a deeper understanding of everything that is essential for us to pass the exam. Please, I believe we all saw the topics that we are treating this evening.
Yes.
Yes.
All right. So by way of repetition, today we are going to be looking at
We can't hear you.
Please, we can't hear you.
come again, please. Can you see the whiteboard?
Yes.
Sir, please. I can't hear you.
Yes, please.
You can't hear.
We can see.
Can you see now?
Yes.
That's fine. So please, the main subject area we are looking at today is numbers. Now, in numbers, we are saying that we are going to focus on base 10 numbers.
Whatever you are saying.
I just said that our topic is going to be centered around base 10 numbers. Sorry, numbers. And particularly, we are going to focus on base 10 numbers. Is it better now?
Yes.
But
Please, is it better now?
yes.
All right. So earlier I asked that what are base 10 numbers? So base 10 numbers are simply numbers that span from 0 to 9. So base 10 numbers, they span from 0 through to 9. And these are the basic base forms of numbers that are used generally. Inti syllabus neka say base 10 numbers no. Your person can say these are the numbers we are going to be using. In order for people not to become so confused, say you can say 2 plus 9 is equal to 11. This addition has been made in base 10. And okay, other bases are, we have base 2, base 3, base 4, like to 12, etc. All those bases are there. Our level, this is what where we may limit ourselves to maximum to base 12. But the syllabus is saying that everything that has been written in the syllabus has limited us to base 10. And the base 10 is what I'm saying, that base 10 is what we use in our everyday additions, subtractions, multiplications, divisions, etc. So please don't be confused with the syllabus saying base 10 numbers. It doesn't mean that you are going to have questions on number basis. Please, am I clear?
Yeah.
Yes.
Please, are we clear enough so we can proceed?
Yes.
All right. So base 10 numbers does not mean that we are going to do number basis. Just that it is telling us that the base in which we are going to do our additions is going to be what we all know as base 10, period. Now, when we are to look at these bases in general, or numbers in general, we have various sets of numbers. Now, when we say sets of numbers, please, what are some of the common sets of numbers that we know?
Even numbers.
Come again. So someone just mentioned we have even numbers. Yes, what else? We have odd numbers.
Prime numbers.
We have prime numbers. What else? We have integers. We have whole numbers. We have count numbers. Yes. Please give me more of the various sets of numbers you know. We have composite numbers. Please let me hear you out. We have rational numbers. Hey, please talk. We just went through the syllabus and they mentioned the various forms of numbers that we are supposed to know. Yes. We have irrational numbers. All right, so let me limit our study for today with these sets of numbers that we know of. So, first of all, even numbers. What are even numbers?
They are numbers that can be divided by 2 without a remainder.
Who just spoke? Is that Paul or Joseph?
Joseph.
Oh, okay. But it seems I'm having a class with only Joseph. Oh. Please, others, let us hear from you, okay?
Even numbers are numbers which can be divided by 2 without a remainder.
All right. So thanks, Joe. So the first set of numbers we are looking at are even numbers. So now, what many are saying is that with even numbers, they are divisible by 2. So let me just say they are wholly divisible by 2. Another property of even numbers are that they leave no remainder. Now, what is more important for us to be able to know is for us to be able to give examples of such numbers. So examples of even numbers,
8.
we can say 2, 4, 6, 8, 10, 12, 14, 16, 18, and so on, right? Next, this is just a quick recap, so please, let's be involving. Odd numbers. Now we understand odd numbers are numbers that are not wholly divisible by 2. Otherwise, when they are divided by 2, it would always leave a remainder of 1, right? And what are some of these numbers? Yes.
3.
Come again.
5. 5.
So 1, 3, 5,
5.
7, 9, 11,
7,
13,
9,
15,
11,
17,
20,
19, 21, 23,
19,
25,
21,
and so
23,
on and so
26.
on. All right. Next, the next set of number we are to know of are prime numbers. So, what are prime numbers?
Numbers which has only 2 factors, 1 and the number itself.
So, prime numbers are numbers that are greater than 1 and have only 2 factors. So, please let's take note. Prime numbers are numbers which are greater than 1 and they have only 2 factors. So that tells you automatically that what 1 is not a prime number. Please, is that okay?
Yes.
Okay, sir.
So that's how the definition alone tells you that automatically 1 is not a prime number, because we are saying that prime numbers are numbers that are greater than 1 and have 2 factors. So prime numbers begin from 2. Let's go. Can someone help me? The first 20 prime numbers: 2, 3, 5, 7,
11,
11, 13,
13,
17,
19,
19,
23,
23,
29,
29,
31,
31,
37, 43,
37,
47,
43, 47.
53.
All right. So and so on, and so on, and so on. So these are examples of uh, prime numbers numbers that we are expected to know about. So now we have made mention of, we've dealt with first even numbers, we've tackled odd numbers, we have looked at prime numbers. What are integers? What are integers?
Integers are positive and negative whole numbers.
Please, those who are silent, are you part of this? So integers are simply all whole numbers, including negatives. All whole numbers, including negatives. Someone also defined it as they are both positive and negative whole numbers. So with this, I'm sure it's quite very easy. Let me call Kwesi. Kwesi, please give me examples of integers. We have already defined it, so give me examples of integers. Kwesi, please, you're on the call. Kwesi, are you with us? Okay, Abba. Abba, let's hear from you.
Okay, we have 1, 2,
Okay, 1.
3, 4, 5, 10, 20.
You are not so wrong. Neither can I say you are so correct. You've mentioned only
Why
positive
so?
numbers.
Oh, I mentioned 5,
Because you've mentioned only positive numbers.
but I mentioned 5.
But that's still only positive. Integers are both positive and negative whole numbers.
-2, -5, negative.
It's okay. Don't worry, it's okay. So we've been able to list quite a number of them. So the next one, Emmanuel Atechi. The next set of number we are here to talk about are natural numbers. So what's a natural number? Natural numbers are the same as count numbers. And one na first near friend counting numbers. No? So natural numbers or count numbers, yes. Ella.
Numbers. Okay.
Ella, I'm not talking no. All right, so Joseph, go ahead.
Hello.
Natural numbers are now we make it from 1 to infinity.
So count numbers begin from 1 to infinity. So those are the natural numbers or the count numbers. Is there a type of a set of number we have not looked at? So we have made mention of integers. And we have also so what are whole numbers? Whole numbers, yes. Anyone to help? Yes, whole numbers. Paul.
Whole numbers are numbers that start from 0.
They start from
0 to infinity.
all right, so whole numbers begin from 0 to infinity. So we have as well looked at whole numbers, count numbers. Next is composite numbers. Composite numbers. So what is a composite number?
Composite numbers are numbers which have more than 2 factors.
Composite numbers. Please, others, please, are you with us? So composite numbers, they have more than 2 factors. So this is more or less like the direct opposite of prime numbers. Prime numbers, we said they are greater than 1, but have only 2 factors. And we are saying composite numbers have more than 2 factors. So please help me with the first 10 composite numbers you can think of.
4,
4,
6,
6,
8,
8,
9,
9,
10,
10,
12,
12,
14,
14,
15, 16, 18.
All right, so all these are various examples of composite numbers that we are expected to know about. Next is rational numbers.
Hey, sir,
Yes,
please, my network went
please,
off when you were on even numbers. Oh.
yes, we just went past that few minutes ago, but you don't worry, you'd have access to the recorded one. So, but anyway, by way of a quick recap, let me just help. So, we said that according to the syllabus, we are expected to know the various sets of numbers that we can think of. Are you following?
Yes, I am.
So, we made mention that we have 1, even numbers, we have odd numbers, we have prime numbers, we have integers, we have whole numbers, count numbers, composite numbers, rational numbers, irrational numbers. There are so many of these various forms of numbers, even including sets, etc. However, for the purpose of our exam, we are going to limit ourselves to these 9 forms or sets of numbers that we can think of. And because the syllabus is saying that we should know or have a fair idea about these numbers, we went ahead to look at what these numbers are. So we began with even numbers. And we mentioned that even numbers are numbers that when you divide by 2, it leaves no remainder. So we gave examples as 2, 4, 6, 8, 10, 12, 14, 16, 18 onwards. Then we also came to odd numbers, and we explained that odd numbers are numbers which are not perfectly divisible by 2. That means that the moment you divide them by 2, it leaves you with a decimal, or it leaves you with a remainder. So we mentioned they begin from 1 and they span through to infinity. So 1, 3, 5, 7, 9, 11, 13, 15, on and on and on. Then the third group, we came to prime numbers. And in prime numbers, we mentioned that prime numbers are numbers which are greater than 1. However, they have only 2 factors. So prime numbers are numbers that are greater than 1. However, they have only 2 factors. So with that 2, we mentioned 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and on and on and on. Next, from that, we came to integers. And we explained that integers are both positive and negative whole numbers. Positive and negative whole numbers. So we know for now that whole numbers begin from 0 and they span through to infinity. So from 0 backwards to -1 to infinity, and then from 0, +1 upward to infinity. All these are various forms of integers. Please, are you with me? Then from that, we went on to natural numbers. Diana, please, are you okay? All right.
Yes, I went off, but I'm okay.
Okay, so whole numbers. Then we came to composite numbers, saying that composite numbers are numbers that have more than 2 factors. And we were just on it when you came back online. So next to that, I asked what a rational number is. So what are rational numbers? And what are irrational numbers? Can anyone help us? Yes. Okay. Let me just leave this example. Then you choose between a rational number and an irrational number. Please, can we see the numbers I've just written?
Yes.
So we have box A and then B. A is 22/7 and B is pi. Which of the following is a rational number? A or B?
A.
Yes.
It's A.
So someone has expressed his opinion. He's saying A is a rational number.
A is a rational number.
Any other? ABS?
Yeah, A is a rational number.
Okay, so she's joining Joseph. Let's see if they'll be right or wrong. Any other opinion?
A is a rational number.
Okay, so we have C here. C is the root of 5. The root of 5, is it a rational number or an irrational number?
An irrational number.
How about B, pi?
Because rational number is a number that can be expressed as a ratio of two integers.
GG. So someone has just given us a wonderful explanation about rational numbers. The rational numbers can be expressed as a ratio of what? Two
integers.
Two integers. All right. So I want to ask a few questions before we make progress. I don't know if I want my right to be so clear for you, but which of the following is a natural number? Which of the following is a natural number? A is -1, B is 0, C is 1, and D is 1 on 2. Which of the following is a natural number?
C.
Abigail said C is a natural number. Lizzie, she's incorrect. Can you help us? Lizzie's iPhone. Yes. Abigail just said C, and I'm saying she's incorrect. So Lizzie's iPhone, yes. Okay, Joel.
C is an example of a natural number.
Joel is also saying C. I'm saying Joel is also wrong. Kwabena Rasta. Okay, Kwesi. Kwesi.
Yeah, the answer is C.
Hey,
Yeah,
so
C.
Okay. Please, can someone tell them the right answer? Now, 3 people have said C and they are all wrong. Who is giving us the right answer? Sarah. Sarah.
Please come and give me the possible answers. I didn't get you.
All right, so we're asking which of the following is a natural number? A, -1, B, 0, C, 1, D, 1 on 2.
Okay. 0.
0. Thank you for making us have the winners for the day. So Abby, Joel, and Kwesi are all right. Unfortunately, I got you with my test. So Abigail, sorry, Sarah, your second chance. 0 is what type of number? So congratulations to Abby, Joel, and Kwesi. The natural number here is 1. Earlier we mentioned that natural numbers are the count numbers. So Sarah, your second chance. 0 is what type or form of number? Okay, Kwabena Rasta, let me hear you.
Okay, 0 is a whole number.
So 0 is a whole number.
Yeah.
Okay, Kwabena, next one, because you've been quiet for some time. 1/2 is what type of number?
1/2. I think
Someone
it might be an
Someone just
integer.
said it. Uh-huh.
It's what rational number.
Obi amu apo onye hwe. All right, so that was just to see whether what we just did, we all had a very good understanding of it. Now, let me see if I can get you a question. Okay. Please, can you see question 13?
No.
Oh,
You can see, right? Okay. Is it better now?
Your screen is now loading.
Oh, okay. Question 13. Can someone read it for us?
it's still loading.
Still loading.
Oh, okay.
WebEx consult and started screen sharing.
All right. Please, let's continue. All right. So the question that I was trying to display was, let me read it out. What is the square root of 256? Square root of 256. And the options were, the options were 14, 16, 18, and D, 20.
15.
Who is answering 16?
Four.
Joel. Oh, okay.
Yeah.
So please, the reason why I went to show that question is, remember when we were going through the exam outline, they mentioned all the examinable areas, right? But unfortunately, I'm not sure you saw square roots. Did we see that?
No, please.
But we saw exponents. Please remember we saw exponents.
Yes.
So what it means is that we are also expected to know some of these exponents. And in my class, I'd prefer that we are able to at least roughly be able to tell quite a number of these exponents. So please, sorry, I have to take you to maybe class 1 or class 2, but let's do this together. We are going to give the exponents or the squares of our first 20 numbers that we can make mention of. I hope no one is going to feel we are doing something that is very childish.
No.
So please, let's do this together. I'm writing these numbers, so you tell me they are squares, and then they are square roots. So this is the first 6. So here is the squares, and when you root it, it will give you the number in its default. So I wouldn't have to rewrite it again. So please, the square of 1. This one, let's go one after the other. Obiabe Kebi. So please don't rush to tell me the answer when it's not your time. Joseph, square root of 1 is
1.
square root of 1 is 1. Okay, then let's make this the square first. So the square of 1 is 1, and the square root of 1 is
1.
okay. The square of 2 is Kuma Beauty Jemfua. Gifty, sorry, Beauty. The square of 2 would give you Lizzie. All right, I think if we are to go wait on them, we will never finish. So please, as many as can help me, let's go. The square of 2 is what? 4.
4.
The root of 4 is what? 2. The square of 3 is what? 9.
9.
The root of 3 is what?
9, 3,
3.
The square of 4
3,
is 16.
16,
The
16
root of
16,
is 4.
is 4.
The square of
4,
5 is 25.
25
The root of 25 is
25,
5.
5.
The square of 6
36
is, and then the square root is what?
36,
6.
6.
The next set of numbers, we are beginning with 7. The square of 7 is what?
49.
49
And then the root of 49 is what? 7.
7.
The square of
7,
8,
64.
64
2,
and then the root is 8.
8.
The square of 9 is 81. The root
81
is 9. The square of 10 is 100.
100
The root is
100.
10. The
10.
square of 11 is 121. And the root is what? 11. The square of 12 is 144. And the root is
144.
the square of 13 is 169. And the root is 13. Now let's move to the next. So you're going to 14, right?
Yes.
Yeah.
So the square of 14 is
196.
and the root is 14. The square of 15 is
225.
the square of 16.
256.
The square of 17.
289.
The square of 18. Yes.
3, 2, 4,
Wait.
The square of 19.
3, 6, 1,
3, 6, 1.
1.
So automatically the various squares, when you root them, it will give you back the same number. The square of
Sure.
20.
400.
400.
The square of 21.
441,
The square of 22.
484.
23.
529.
529.
Oh, teacher, my boy Fuana.
Oh, me both.
Listen, the boy Fuana. Me so crying and beto yo.
Adai.
I said,
Not Taranana.
Please, are they referring to us?
I don't think so.
Ah. Okay, the square of 24.
576.
And then 25.
25.
625.
So with all these numbers, you see now we've been able to write the first 25. But bear in mind, the exam outline said that we should know about exponents. It did not mention about only squares, right?
Yes.
Yeah.
That means that what I have just done, we have only done the squares, which means we are multiplying n by n.
Yes.
It could also be given in the exam that say n times n times n. So now we know that by this it means what n times n will give us what n square.
Yes.
N times n times n will give us what n cube. It could as well be n times n times n times n. Now all these are what exponents. The exam outline is saying that we must not only look at the squares, we must as well look at what the exponents. So I may not be able to let us go through all numbers on their exponents, but what I can easily draw your attention to is on the squares because those are going to be the most common ones. So by exponents, what we are trying to say is that 2 exponent 3 simply means what? Can someone
2
help?
times 2 times 2.
And that would give us
That will
8.
give us 8.
So next is 5 exponent 4. That would mean what? 5 by 5
Times 5
by
times
5 by
5
5.
times 5.
We have 25 by 25, and that will give us what? 625. So please, what NTC expects you to be able to know is that know what these various forms of numbers are, as well know how to operate with these numbers. There are 4 basic operations. Before we move on to the operations, if you remember clearly from the exam outline, we said that we are also supposed to know what factors. Factors of numbers.
Factors.
Hello, guys. Can we move on to factors of numbers?
Yes.
Everyone is okay.
Yeah.
In our next meeting, come next week, Monday, we will not be doing any teaching, any class. I would send you the questions. You'd come with your questions to this online platform, then we'll be solving it together. That's why I want us to do all the necessary discussion we need to do under the areas we have just looked at. So hopefully next week we'll be solving questions in choir. So please, if you know you have any challenge, and then also Oche and sign, not next week. All right. So please, what are factors of numbers? So factors of numbers are simply the numbers which, when multiplied, would give us a given number. So factors of numbers are numbers which, when multiplied, would give or result would give or result in a given number. Partial definition, what I say?
Pachome.
Yes, what you saying?
Meaning say two numbers you multiply and then it will give you a particular number. So example, like let's say 12. 12, you have 6 times 2 giving you 12. You have 12 times 1 giving you 12.
Okay. That's fine. So now from what Ella just said, so 2 times 6 is going to give you what? 12. So 2 and 6 are factors of 12. Please, do we get it?
Yes.
So any two numbers that when multiplied would give you a particular number are called the factors of that number. Is that very okay with us?
Yes.
Yeah, please.
Please, if you don't understand this, it would give you a word problem that would demand you to use this, and it will marvel you how we are going to apply the word problem here. Okay. Should I move on to the word problem question, or let's throw more light before you get to that? Let's try the question. Please kindly write this question down.
Can you please help me with how you got the square?
Please, are you ready for the question?
Yeah, please.
Okay, so please, I'm reading out the question. Tom has 18 boxes of pens. Are you listening?
Yes, please.
Yes.
You can say Tom. Kwesi. So Kwesi has 18 boxes of pens to pack into cartons. He wants to pack the same of boxes into each
I
carton.
can't hear you.
Come again.
I can't hear you.
Okay, so I'm reading
The question again.
Oh, can you see the screen? I've written the question on the screen. Oh. So Kwesi has 18 boxes of pens to pack into cartons. He wants to pack the same number of boxes into each carton. Can you see the question now, please?
Yes.
Okay.
Yes. Please, I can't see the question.
Hey, yes, the question has moved. I don't know.
Please, can you
One
read,
I'm saying that's the
read
question now.
over the
One question again. When you saw one question again, now show yourself. You will still solve it. Please, the question has come back. Why? Ojani is Swaba. Kwesi has 18 boxes of pens to pack into cartons. He wants to pack the same number of boxes into each carton, such that each carton contains 3 boxes. How many cartons can he fully pack? Our question here is too simple. Let me make it 4. Please, can you see the cancellation I've done? Oh, wait there.
Yes.
Oh,
Yes,
why is this
please.
thing running away again? Please, the question will come back. Don't worry, okay?
Wow, sure. Ah, mas eu começo.
Please, can you see it now? So Kwesi has 4 boxes of pens to pack into cartons. He wants to pack the same number of boxes into each carton, such that each carton contains 4 boxes. How many cartons can he pack? If you are done with your answer, kindly let us know. Please, anyone done? Kwesi has 18 boxes of pens to pack into cartons. He wants to pack the same number of boxes into each carton, such that each carton contains 4 boxes. Lizzie, I have just read the question. So if you can't see, don't worry. Kindly follow us. I read it out. Kwesi has 18 boxes of pens to pack into cartons. He wants to pack the same number of boxes into each carton, such that each carton contains 4 boxes. How many cartons can he get?
4.
Please, who is done, please?
So I had 4.
Okay, so someone had 4. Let's wait for the others. Please, any other person who is done?
I had 4.5.
You had what?
4.5.
4.5. Okay. So the first person said he had 4. The next person had 4.5. Okay. Any last person to suggest an answer, then we solve it together. Last person.
I also have 4.5.
Okay. Abigail, you have unmuted yourself. Tell me your answer. Yes, Abigail.
William, if you online, see my table, so I'm not solving it.
Yes, what about question in that? So tell me your answer.
I'm not solving.
Okay, please, can we solve it together?
Yeah.
All right, so a few minutes ago, we were looking at factors of numbers, and we said factors of numbers are numbers which, when multiplied, would give you a particular or a given number. In this case, this question is trying to test our knowledge on factors of numbers. And the question has given us the number to which we want to obtain its factors for, right?
Yeah.
Yes.
Comrade, start of the
Yeah.
Okay, so your answer.
Okay, the answer is 4.5.
Okay. So before I was explaining that the given number here is what? Is 18. And we have, with factors of numbers, we know we always have two given numbers, right? That results in 18. So what other factor, when multiplied by so please, let's first list the possible factors of 18. So the first step,
We have
We have
um
2.
and
the
then
screen went off. Sorry.
1.
Let me share the screen again.
Please, can you see the screen now?
Yeah, we can see the screen now.
Okay. So first, let's try to list the factors of 18.
1,
So we
One.
have 1,
1 and 8
2,
itself.
So 1 and 18 itself.
3,
Yes, we have 2
9,
and 9.
3 and 6.
3 and 6.
3 and 6.
Okay. So my pen is back. We have 1 and 18 itself. We have 2 and 9.
Yeah.
3 and 6.
We have 3 and then 6. Is that all? Is that all?
Mm.
Please, is that all?
Yes, please.
Please.
Okay, so these are the known factors of 18 we have. And according to the question, it says that Kwesi has 18 boxes of pens and he wants to pack the same number of boxes into each carton. So before I come to the mathematics of it, let us do the logic behind it and see. So let me call this carton 1. Carton 1, how many boxes of pens would he use?
18.
4, right?
Yeah.
Now let me just call here boxes left or left boxes. Ignore the grammar. So opake carton 1 we are. How many boxes in Rebecca?
14.
14.
Then we come to carton 2. And also how many? 4.
Oh,
How many will be left?
10.
10.
Let's come to the third carton. And also 4. How many will be left?
6.
6.
The final carton 4. 4. How many will be left?
2.
Now let's go back to the question.
Please, can you go over what you were doing recently?
I should go for what I was doing.
Yeah, I said go over because this one the affirming so.
What I'm doing is not mathematics, so what I'm doing is logic. We come to the mathematics behind it.
Okay.
See, Kwesi 18 boxes of pens. Our person packing egu carton mu, right? And pen box near 18. Our person packing egu carton mu. But all pack egu carton mu no say or person carton be the same number of boxes. He wants to pack the same number of boxes into each carton, such that each carton contains 4 boxes. Is that okay? So calculation A say 1. For the say for the first carton, no. Yeah, the 4 boxes na shim. Tebeka boxes ne saying. Sanka beka 14 after I pack the first one, right?
Yes.
After for the next carton. And so I pack 4 boxes. After Beka saying, I beka 10. The third box, I pack 4 boxes. I beka saying, I beka box is no 6. Or for the 4th box, no pack 4 boxes, sir. After Beka saying, I beka 2. And it's also a person pack the same number of boxes per carton. And how many cartons would he get? Please, is the question clear now?
Yes.
So he would get 4 cartons. Hello.
Hi.
Please, those who had 4.5, can you now explain your answers before we come to solving it itself?
I divided the 18 by 4 and I had 4.5. And
Come again.
18 divided by 4 and I had 4.5. That is how.
Okay. Ntika, Sanoka, you are not so wrong. But if you have read the question very well, I see the same number. Box is now. But now, if you have to share the remaining 2 boxes, it is only 2 of the cartons that can get a number. Hello.
Hi.
Hello.
So once you
Is
saying that or the good box carton be a number of cartons owning them ayepe. So ankawunya we no, you should not divide to get a decimal because you're looking at the same number. So the approach you used wouldn't have been so wrong if only you ended at the 4.
Okay.
Okay.
Please, any other person?
Yeah. That's one more question. Per the
Yes, please
calculations
ask.
that, per the calculations now I know. You said the first cousin will be 4 boxes. second one to be 4 boxes, third one will be 4 boxes. Meaning that a Becca 2. She's a Becca 2 there.
Yes.
Let's say it's a 3.5 boxes. But that's
No.
it.
A 4.
Yeah. On sale. The per the calculation is now 18.
Yes.
What's it for film? Rebecca 10 right. And at 10, what's it for film? Rebecca 6. What's it for film? That would be the third one. Then it will left with 2. And
Okay, Abby.
yes, sir. And yeah.
My fan Makuma say, I think say you are almost missing out something. So the first cutting new box is near saying 18.
18.
Yeah.
Into the first 4 boxes film when you one cutting.
Yeah.
Now the next cutting is Sunny. Into the first 2 curtains now to film will 10, no, not the second one, not the first one, sorry. So the third curtain,
Now benya 6.
yes. Then the fourth curtain and so now we 2. So by the time I get 2, no, they can actually 4 curtains, dada.
Okay.
It's going to be 4 curtains and 2 extra boxes.
And I think that the 4.5. I think that they are making some EB there because the or can I say the point now baba person say a half of it and I'm about.
Yes.
Please, can
I think that I think that
the question was saying that he wants to pack the same number of boxes into each carton.
Hello.
Box
hello.
the same number of yes.
Please, can I ask a question?
Sure, you can ask.
But in factors, do we have a decimal?
So that is why we are saying that the answer that they had, which is 4.5, is incorrect. The right answer is 4. So you can only get 4 boxes.
Okay.
Okay.
So please, it was just a teaser question. Come again.
What will happen when the 2 boxes that
So the 2 boxes that will remain. The question is saying that but we want to know how many curtains are obenya. So packet 4. How many curtains are and obenya? So packet no 4. Into the focus of the question is not saying a cow. Is that okay?
Okay. Yeah.
The focus of the question is not how saying a beka. Yebusa saying a yebenya, curtain saying yebenya. So packet be 4. So this same question, the examiner can now change it and ask how many boxes would be left.
That would be the 2.
In that case, the answer would have been the 2.
2. Yeah.
Okay.
Please, is it okay?
Sure.
Yes.
So I was only trying to use this question to draw our attention to how sometimes questions can be when the examiner wants to test your knowledge on these areas. Now, beyond this, beyond factors, we also have multiples. Please, we didn't start on time, so if the time is past 9:40, please pardon us. We won't take much of your time today, so please don't worry. Multiples. Now, what are multiples? Multiples are simply the results or the product when you multiply a given number by counting numbers or count numbers or by natural numbers. In this, what the number be? Example, 11. What 11 and multiply natural numbers are? The obenyano are called multiples. Now we know that natural numbers or count numbers, they begin from what? They begin from
1.
1 through to infinity.
Infinity.
So multiples of 11 in this case would be what? 11,
11,
11,
22, 33,
33,
44.
55.
In that order.
Yes.
It is not likely that NTC would ask you list multiples of a given number. They will not ask you that. However, they have explained that they are going to ask you questions with these same things, but this time around in multiple step problems. That simply means or word problem involving multiples. And a typical example of such a question is why am I finding it in here? So Abba goes to the market every 3 days. Then Abby goes to the market every 5 days.
Mama Joyce number no.
Hey, Kabana Rasta. So
Yeah,
Abba
but
goes to the market every 3 days. Abby goes to the market every 5 days. If they met at Bantama Market on 2nd June 2024, when next would they meet? When next would they meet for shopping of groceries? Please, is the question clearer first to understand? But your question, Madao.
Yes.
Yes,
So Abba goes to the market every 3 days. Abby goes to the market every 5 days. If they met at Bantama Market on 2nd June 2024, when next would they meet for shopping of groceries? So this is a typical question of multiples. Can you see they are testing you on multiples? But your question is down. Do we see say exam no air test our knowledge on multiples of numbers? And I know one is seeing that.
Me who say multiple.
What you say?
For this one, I can't see say multiple.
I don't see
Okay.
it as multiplication.
Okay.
I can't see it as.
All right. So you let me explain it over here. Now after I explain, you get it right. Numbers bend down one question. You saw 3 and you saw 5, right?
Yes.
Indirectly, the question is also test why I say, what are the multiples of 3? What are the multiples of 5?
So 5.
Who we are? What is the LCM? So let's ignore the question and let's solve these multiples. So multiples of 3, let's list the first 10. Let's go.
3, 6, 9, 12, 15, 18, 21, 24, 27, and 30.
Now of 5.
10, 15, 20, 25, 30, 35, 40, 45,
Now, let's come to the LCM, the least common multiple. Number ben what 3 multiples, let's have 5 multiples. Let's begin with
15.
3. Is 3 here? No.
No.
6. Is 6 down here? No. 9. Is 9 down here?
No.
12. Is 12 down here?
No, to 15.
15.
15 and
15 is
30.
also here. So
And
we are looking for the
32.
least, the smallest one.
15.
Okay.
LCM is what? 15.
15.
Now, let's apply this knowledge we have gained there back to the question. Is that okay?
Yeah.
Now, the question again. You say, Abba, 3 days, the Abba Kudija. Is that okay? Abba is Kudija every 5 days. And he said, Eda Omuna Kushia Ujumno was 2nd June. And that may not me share.
Please, can I try?
Oh, we are coming to solve it together, don't worry.
Okay.
So now let's see. Abba. Inti ekame kwa me the English and I best of the work here and then masa make us say Abba Kojum on the 2nd June, right?
Yes.
That ben be na Abba Kojum be on the 5th June. Is that okay?
Yes.
Yes.
Yeah.
What's that on the 8th June?
8th June.
8th June.
When you said the me your friend multiples there.
Yeah.
Yes.
You indirectly let's continue. Obesa could be my 11th June.
11th June.
Obeko be my 14th.
14th.
Obeko be my
17th.
17th. Obeko be my 20th June.
20th June.
Obesa could be my 23rd.
23rd.
I met us one. Obesa be could be my 26th June.
26th June.
29th June. Yeah, to us one. Now Korea June has 30 days, so
July.
2nd July, right?
Yes.
Now call 5th July. 8th July. 11th. 14th July. In that order. I'm interested in my Abigail the also. Abigail also called every 5 days, right? That only Apakusiano was 6th June. After 5 days, Bersing.
7th June.
7th.
The next 5 days, Bersing.
12th June.
12th.
The next 5 days, Bersing.
17th.
17th.
The next 5 days, Bear 22nd.
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 The next 5 days, Bersing. 27th.
27th.
The next 5 days, Bear 2nd July.
July.
Afi. Ye peda aba ene abi kwakushia. Inti 6th June any first day omkoshia inti no nka ho, right? The next day 5th June no abi ko market da abi 8th June abi ko market. Hello.
Hi.
8th June abi ko market na da abi. 11th June abi ko market.
Da abi.
14th June abi ko market.
Da abi.
Abba.
Sorry, Abba. No, Abi na yeka. Yede Abba compare Abi. Now, 17th June. 17th June. Abba ko market. Abi so ko ya na.
Da abi.
Hey, check you.
Yes. 17th. Okay, yeah.
So we are seeing that, yeah. Hello.
Hi.
Hi.
Yeah, so say side you in mathematics, in numeracy, you have a friend of multiples as in work the multiples. Is that okay with everyone?
Yes.
Inti Afi from the previous solution earlier I said we should simply find what multiples of 3 and multiples of 5, right?
Yes.
But you're finding multiples no. What did we get? We had what?
15.
15. That means that some BMA they'll meet after what? 15 days. Please, are you following?
Yes.
So if they will meet after 15 days, you had you. The first day they met, na 2nd June, right?
Yes.
2nd June. What the 15 days come by saying?
17.
7.
Please, do you get it now? So rather than you coming to write down these things, I work dates, you simply find the LCM, and that is all.
I don't know if I would have got it wrong. I
Okay,
had the same.
let's see.
I multiplied the 3 by 5 and I had the 15.
So multiplying 3 by 5 no near wrong go. But sometimes, example, sankaye 8 and 5 are. So 8 and 10. And now multiply ubenya 80. But that is not the LCM of 8 and 10. Into answer now in that case they are wrong. Into approach no near wrong. Only that sometimes a correct answer. Other times a wrong answer.
Okay.
So please, all the time, simply find the LCM, then use the LCM to complete your answer. I'm sure so you've seen past questions around that. Yes, maybe are 2 sirens, one rank at 8:15, another rank at this time. If they rank together at this time, when next would they ring together? Please, have you seen such questions before?
Yes.
So when you see all such questions,
Hello, sir.
all those
Please.
questions are trying
So
to
when
test
you use the
you and want you to use what we call the multiples or the LCM. Please, is it very okay?
so please, I have a question. So
Sure, you
if
can ask,
find the
please.
LCM, but the LCM that we got is was 15, but the answer
Yes.
here is 17. So how did you get the 17?
Okay. So as I said, one same question, we can use that to ask so many questions. Question number 1 is, in how many days would they meet again? In how many days would they meet at the market? The question can say, in how many days would they meet? And saying
15.
in 15 days. And now the same question, the examiner can ask, when next would they meet? Please, do you get it?
Yes.
Yes.
The question can say, when next would they meet? The examiner is looking for the date. And he said, Omudi can share 2nd June. That's what Mr. share in 15 days. Then you do the mathematics. Is that okay?
Yes, please.
And for the purpose of this question, the examiner was asking you, when next would they meet? And that was why we had the answer to what? 17th June
17th June.
2024. Is it okay now?
Yes, please.
Yes, please.
Please, any other question?
Please, when we are writing the exam, are we allowed to use calculator?
Of course, you are allowed to use calculator. Any other question, please? So if there are no questions, it means you are ready to solve at least 20 objective questions from what we have done so far.
Wow. Just this one.
Yeah, just this one. Added also. Any 10. Any 10 pana.
So
No,
20
I'm
will
just
be okay.
Come
I'll
again.
get varieties. I said 20 will be okay, so that
That's fine.
I learn a lot.
All right. So please, that will be all for today. Unfortunately, we could not go so far beyond like, but it's good. So far, you've been able to do or to tackle. Please, let's look at the exam content. We've tackled base 10 numbers, looking at decimals, and we've not done addition and multiplication, division, and subtraction of decimals and integers. One day we'll talk about it. I may not teach it, but I'll give you as part of the questions so you solve. So here it will apply, or it would imply you'd have to apply your knowledge on board mass over here. An addition of decimals. Please give me 10 minutes to take addition of decimals, please.
okay.
Come again, please.
We
And
are
our time corridor.
we are ready.
All right. Please kindly try out this question for me. 0.05. 0.05. 0.05 plus please, what answer did we get? 0.05 plus 0.3. Yes, answer. No calculator, please. Abba. Ella. Prisleniama. You are already unmuted, so please talk. What did you get?
Yeah, Rain.
Please, I'm not saying read what I'm writing. Tell me the answer. Hey, Patron, to be answer the question.
I had 0.35.
How did you get 0.35?
So what I did is I 0.0.
So Joe, you don't explain. Someone else did it. So let them explain. Lizzie, you are unmuted. Can you talk?
I also had the same answer, 0.35, but I just
So how
added
did
it.
you?
I think I moved the 0.05.
Mm-hmm.
I skipped. I don't know how to, like, may I skip counting from the decimal. That's the 0.05.
Yeah, skip counting.
Yeah, like from
Wait,
the decimal.
wait, and yeah, senpai, can I say like chow? Baby, I also have a chemio. Okay, so have you all seen the steps I've written down here? Step 1 is what? Rearrange what? The decimals, right? Step 2 is ensure the decimal points are in line. And the third thing is solve per the operation sign. So what it means is that step 1, rearrange the decimal. So it's going to be at 0.05 plus. Step 2 says that ensure the decimal points are what? Are in line. Next one is 0. What? 0.3. And can normal addition, Quebec say 3 no should be like this: 0.05, 0.3. Now about base 0.8, sorry, 0.8. This is wrong. Please, are you watching the screen?
Yes.
Say decimals are, we expect say decimal point must be in line, irrespective of how long one of the decimals is. Is that okay? So in this case, a bare 5 plus nothing, and that will give you what? 5. 0 plus 3 will give you 3. You bring a decimal point, then 0. So always, whether you are solving addition of decimals or subtraction of decimals, it is expected that you arrange them in vertical form. Please, are you paying attention?
Yes.
It is always advisable that you arrange them in vertical form. Now, I know that some of you have seen past questions in the old exam. In the old exam format, there were past questions that some read like a teacher gave a student a question to solve. And say the question was 0.05 plus 0.3. The student answered the question as 0.08. Then NTC would ask, hey, what is wrong with the student's solution? Please, have you all seen such question before? Such past question? Hello. Please, are we together?
Yes.
Yeah.
So in a previous exam, sometimes they would say with the same question we just solved, a student answer the question 0.05 plus 0.3 is equal to 0.08. A, what is wrong with the child solution? So can someone tell us what is wrong with the child solution? Yes, what is wrong? Please, what is wrong with a child solution?
I would say he didn't consider the decimal places.
That is very correct. Then B, explain to the student how to obtain the right answer. Yes, I'm listening. Oh.
Recording in progress.
Hey, Basho, can someone explain it? Then we just close. Joseph, can you help?
Okay, to get the right answer here, that you must arrange the decimals.
And one steps now, mature now.
Yes.
Uh-huh.
You must arrange the decimals in vertical form, in the sense that the decimals will be at their rightful positions or place.
Mm-hmm.
So that is.
Then now you solve it.
Yes, 0.
And want to know. So the steps we just looked at a few minutes ago, and one and there, you just state, but this time around you state it and you solve it at the same time. And then in the previous exam, in that way, you score the full marks.
Okay.
Now, I don't expect that they would ask similar question in your exam because of the moderation or the change that has come with your form of the exam. In that, you're going to have almost all the questions to be objectives. So you may not have a question like this.
Okay.
But this is what you can also prepare on as you get ready to sit for your exam. You can come for today. Hopefully tomorrow we'll all be able to come on board early enough, having literacy and then essential skills at the same time. If you have any concerns, kindly let us know and we'll do our best to help you understand your questions. Please, any further questions or concerns before we call it a night? All right, no questions. Joseph, can you close with us a prayer?
Okay, we are praying. Daddy Lord, we thank you this evening once again. We started with you and you've been with us. So far, so good. Whatever we've learned, we pray that may you let it stick into our minds so that in the future, if you are to give account on it, we can be able to account very well. We thank you and we pray that may you protect us as we're going to our beds. Watch over us. Tomorrow in the morning, we give thanks and glory to you. In Jesus' name we pray. Amen.
Amen.
Amen. So thanks so much.